Good afternoon, everyone. My name is Zhong Chenzhi, and I will introduce my recent research on the title that What language do Japanese specialized large language models think in? The background is that the mainstream LMS, such as the Llama 2, they are trained mainly on English state. So for those English-centric model, even when process other languages, the intermediate layers language, also known as latent language, is English. And this picture shows that when the Llama 2 process such a translation prompt, translate from the French words to the Japanese word, the answer should be Hana. But if you look inside to the intermediate layers, you can see the model first give the English answer flower, and only at the final layers, it gives the Japanese answer Hana. So we are curious that what's the latent language of the Japanese specialized LLMs? Would they think in Japanese or they still think in English? And for Japanese specialized LLMs, actually there are mainly two types of them. The first type is the LLMs based on English-centric model with continual pre-training in Japanese state. For example, is Swallow. And the second type is the LLMs trained from scratch on balanced English and Japanese state, for example, AAMT. So do these two types of model work similarly is also a question. And in this experiment, we will use the logic lens. The logic lens can, by projecting the model's intermediate representation onto the vocabulary space, it allows us to observe how the model predicts the next token layer by layer. We can see the probability over the vocabulary. So for experimental settings, we will test three types of model. First, the English-centric Llama 2 and the Japanese continual pre-trained model, Swallow, and the from scratch model, LMJP. This table shows the proportion, language proportion, the pre-training day of those models. And dataset, we manually constructed a word-level parallel dataset containing four languages, English, French, Japanese, and Chinese, totally 166 examples. And based on the dataset, we will test those models with two tasks. The first is the monolingual close task. The prompt is like this. We will first give few short, and at the last row, we will let model to guess the answer. And at that time, we will monitor the probability for the English answer and the Japanese answer at each layer to see how the probability change. And the second task is the cross-lingual translation task. It will translate from one language to another. The prompt will be like this. So first, I will show the result of the monolingual close task. The close task is did in will use Japanese to ask those prompts. So you can see even when conduct the Japanese close task, the English-centric model Llama 2 will still think in English and only give the Japanese version answer at the last few layers. But for these two Japanese specialized model, they can arrive at the Japanese answer at the very early layers. But also you can note that the Swallow, it uses a mix of English and Japanese, but the MJP is fully thinking Japanese when conduct the Japanese close task. And the next part is the translation. We first translate from English to the other four languages. So from left to right, we gradually change the target language, and the target language get closer to Japanese. And you can observe that the probability of the English decreased while the probability of the Japanese increased, which means the latent language that has a higher similarity to the target language will have a higher probability in the intermediate layers. Also, you can observe that for the continual pre-trained model Swallow, in its intermediate layer is always a mixture of English and Japanese. But for MJP, in some settings, they can fully think in English to process those tasks. The next, we will translate from the four different languages to the target language, Japanese. So from left to right, as the source language gradually get closer to Japanese, you can observe that the probability of English decreased, while the probability of the Japanese increased, which means the source language also will influence the probability distribution over these two latent languages. The latent language with a higher similarity to the source language will have a higher probability. Similarly, we can observe that in all settings, the swallow's intermediate layer is always a mixture of English and Japanese. But for MJP, in some settings, while both the source and the target language are close to Japanese or East Japanese, the model will fully think in Japanese to process those tasks. And after investigate the latent language of the Japanese specialized model, we are also curious, will the latent language affect the model answer those culture conflict questions? Because that each language will represent actually a culture. So if you ask some question like the month when the new students start in Japan, the answer for Japan actually is Shigatsu, but actually, when Llama, the English-centric model, answers such a culture conflict questions, in its intermediate layer, you can see the answer September. Actually, September is the month when the new students start in the US, which means the Llama actually will first think of the answer for the US culture content, and then think of the answer for the Japanese culture content. So we want to validate if the model will answer those culture complete questions follow such a procedure. So we did a little experiment. And the model we tested as before. And for data set, this time we manually construct a culture complete QA data set with 49 examples. The experiment will contain 3 steps. So at the first step, we will ask the model about the US and Japan in its respective language like this. And at the second step, we will record those answers as the answer for the US and Japanese culture content. Yes, we use the model's response as the answer, but we did not use the real world answer. And at the third step, we will ask those questions in Japanese again, but this time we will use Hongoku instead of Japan and monitor the probability of the answer in the US and the Japanese culture content. The result is like this. So because Llama is thinking English, so even when answer those Japanese questions, you will first give the US culture contents answer, and only at the final layers it gives the culture for the Japan culture content. But these two Japanese specialized model, because they can think in Japanese, so when answer those culture conflict questions, they can always first think of the Japanese culture content at the very earlier layers. And also the swallow is produce a mixture of answer for the US and Japan culture content, but the MJP, because it can fully think in Japanese when process a Japanese task, so it's unaffected by the US culture answers. So based on those experiments, we have some conclusions. So the first is that Japanese specialized models can use Japanese as their latent language, which means they can think in Japanese. And the second is that the probability of a latent language is influenced by the both source and target language. Higher similarity will increase the probability for that latent language. And the second is the latent language will affect how the model answers those culture conflict questions. And for future works, we plan to evaluate whether Llama's intermediate layer English answer, the accuracy will be higher than the target language answer when process the non-English benchmarks. Thank you for listening. That's all.
Okay, so thank you very much for the presentation. It's a bit quite interesting. So, okay, so yeah, the llamas, so the examples of the starting month of the semester. It's very interesting that the llama answers September in the intermediate layers. And so the question is, what kind of what kind of information changes the llama to answer April? can.
April is actually the English version of Shigatsu, like so
But
it's
what in English in US the September is correct answer, but in Japan the April is correct. But so what makes these changes?
that's
Of
a
course it's very difficult question, but why the LLM can change that?
because actually the answer is also about Japan, so the model will try to get the right answer layer by layer. So at the very beginning,
Hmm.
maybe because it's think in English, so you always first think of the answer for the US culture content, and while you process the answer layer by layer, maybe the attention will fall on the country's name Nihon, so it gradually uh,
Hmm.
fix this answer, gradually get closer to the right answer. Maybe it's like that.
Okay, so this procedure is almost the same to the every questions
Yeah.
or specialized for this one? Or it's always the same?
It's always because we only monitor the answer for the US and answer for the Japan, so we didn't monitor the this answer, the Japanese answer, but in English version. So
Hmm.
uh, we think there should be another curve here that
Hmm.
represents the that answer, but we will conduct this experiment in the future, maybe.
Hmm. Okay. Oh, it's very interesting. Hmm. Okay. So is it possible to this kind of tendency can be used to make the LLM to answer more correctly?
Yes, we actually have some other research that to use this phenomenon to enhance the multilingual probability. So we will
Hmm.
maybe do some research in the future to
Okay.
try to how to use this phenomenon.
Okay, so that's great. Okay. Okay, so thank you very much for the presentation.
Thank
はい。
you very